This conference will now be recorded.
Hi, good morning. Hope you're able to see my screen and also are able to hear me. So
Yes,
one
sir.
of you
Good
please
morning.
confirm it. Good morning. Okay, so you're able to see my screen.
Yes, sir.
Okay, that's great. Hope you are in front of your computers. And anyway, a lot of coding will not be needed, but let's continue with our second project, that is our predicting the fair transaction price for a real estate appraisal company. That's what we are undertaking at the moment. And uh, we will continue with wherever we left in the last session. So in the last session, we have actually explored the data set and tried to understand the distributions amongst the numeric features first, and then we looked at the distributions amongst the categorical features. Okay, so basically we have used both the visualizations as well as using some statistics and metrics. Also we looked at it, and that is the way we try to understand the data. We start with some visualizations, and then we figure out some unusual things in the data, and then to explore further, we will use our pandas skills and kind of figure out using some statistics. And what we did with respect to numeric features, first we plotted various histograms of various numeric features. Wherever we got a little bit surprised, we looked at the particular histogram, and then we looked into the descriptive statistics of all numeric features and looked at individually all the metrics. And we figured out a few issues already, and we are making notes at the moment. When we looked at the basement feature, actually should be a binary indicator variable, yes or no, or 1 or 0, but it is stored as a floating point number, and lot of blank cells are there. So anyway, we will uh, clean it when we come to the data cleaning step. And also we looked at the lot size. When we did the histogram, we found that while most of the lot sizes are on one side, actually one big bar we have seen and very small bar, but it has made bins up to 1,20,000 square feet. So 1 million kind of square feet lot size is there. So there is some problem. There are some outliers with respect to that lot size. Means some properties that should not be in our data set may be there. Again, we are not confirming anything. This is what we explored and made notes. Okay. Now, today what we will do is that we will further continue our exploration. So after having done basic information, we explored it. After that, only numeric features we tried to understand. After that, we understood only the categorical features. Now it is time to see how do we understand things. Put a categorical feature on the y-axis and look at some numerical feature on the x-axis and look at some visualizations, and after that some statistics as well. That might give you, let's say you have a question, okay, I have two property types. One is apartment condominium type property, another is independent house kind of property type. That is how our data has. In the categorical feature of property type, we have two classes. And let's say you have an idea, okay, let me figure out which of the type of houses are sold at higher price. Then maybe you have to see the information together, the property type on one side and the transaction price on another side. So those kind of things we call them as segmentations. So we will do that. And after that, the fifth step in our exploratory analysis is try to understand numeric features with other numeric features. How are they behaving together? That analysis statistically is called correlation analysis. That also we will do, because while we are understanding our data set, we are using a template of 5 steps. So why we are doing this template? So that any new data set of new problem you are having, but still you can do these 5 steps to quickly grasp the data set, so that the next 2 steps are very important. Those are data cleaning and also feature engineering. Those 2 steps we have to get ready. That is why we are doing this. I know we are going slow, but in the first project let us go slow. Then it becomes a habit for you to, whenever a data set is new data set you are looking at, you do these steps, make notes, and then quickly change things and all. So I want this to become a habit for you as a data scientist. That's why intentionally we are going slow. And also whatever pandas syntax of all these visualizations, keep remembering them, keep practicing, then it will become easy for you to move fast. Okay, let's get going. So this is where we are. Our project, we will do it in 5 big steps. We are in the first big step, that is exploratory data analysis. 4 more steps are there to complete our project and build a professional grade machine learning model, which we will do actually. In the first step, major step, I further divided into 5 sub steps. Okay, and we have already explored basic information. We explored in the previous session distributions of numeric features in our data set. Then we explored distributions of categorical features in our data set. Today we will look at segmentations, and after that we will look at correlation analysis. 2 steps we will do today, so that our first major step will be completed by today. Okay, so segmentations. So segmentations are a very powerful way to cut the data to observe the relationship between categorical features and numeric features. Okay, so we have in our data set 3 categorical features. One is property type, which has 2 classes, and we have wall, exterior wall type, and we have 16 classes in that. And also we have roof, which has again 16 classes in that. But actually we will be more interested to see property type with respect to rest of the numeric features. Like I want to understand how my property types and transaction price are related. Is it making some common sense? Whatever we know generally in real estate, common sense information, is it following that or not? I want to see. Or maybe I want to see my property type and square footage. So apartments have more square feet, or independent homes are having more square feet. I want to see, because common sense says that uh, actually independent houses will have more square feet. So we will look at whatever makes interesting for us from the property type with the rest of the numeric features. We can do first a good visualization, and in the visualization, if we see some surprising things, or we want to understand further the visualization, we can do some statistics as well. Anyway, we learned all these things when we did our pandas exercise, but we will just repeat, and I want you to keep these things in your mind. So first let us look at some visualizations. Okay, we will do that coding. Just I'm explaining you first. Okay, this is a very interesting visualization of transaction price on the x-axis, and my property type on the y-axis. And property type has 2 classes. First class is apartment, condo, townhouse. That is how they named it. One type of property. Another type of property, single family. Anyway, in India context, we have apartments and independent homes. Okay. Anyway, this is American way, so we have put that way. Okay. So what we did here is that we are segmenting and viewing my property type with another numeric feature in my table, and that numeric feature is transaction price. And this plot is called box plot. Okay, it has, we can plot it using our SNS dot box plot. And if you send the arguments what you want to be on the y, x, what you want to be on the y, and what data frame you want to pick data, all that if you give, it will plot. But it is more important to understand this plot, what does it really do. So basically it is doing two box plots for each of the property types for transaction price. So if you look at for apartment type class, this line is there. Okay, 1 minute, I don't know. This line and this line, these are actually median. Okay, so what does it really mean? Apartments type property, they are somewhere 350,000 or something like that, the median. Okay, middle point, center. And single family homes, the median is around 450,000. So basically single family houses generally are more expensive than apartments median wise. Okay, actually this bar, this side line and this side line are nothing but your min value, and this is your max value. So minimum somewhere 275,000, maximum is around 425,000 for apartment, and that's what you can see the numbers also later. But this is a box plot to understand I'm talking. So this is min, this is max, this is median, and this side box is called Q1, 25th percentile price. Then this side of the box, it is Q3. Okay, so when we plot this, we can understand these numbers, and when whether something is making common sense or not. If I want to know which basically by looking at the medians and comparing between the property types, I know that single family homes, independent homes in our terminology, they are tend to be more expensive than apartment type of properties. The medians are there. Okay, that is one way to understand. Yes, it's a common sense. Great. Then if you look at variability between Q1 to Q3, here actually I'm plotting not transaction price. Just look at it here. This is my square footage. I'm seeing now, I got a little bit curious, and I'm plotting square feet on the x-axis and my property type on my y-axis. So what does it tell me? Generally, larger homes are independent homes. Okay, again, single family homes are usually larger. The medians are higher. Then also variability. An apartment varies from some 1,000 to 2,000 square feet, whereas a single family home, independent homes varying from 1,750 to almost 4,000 square feet. So variability, the Q1 to Q3 range is larger in independent houses. So basically this kind of visualization is very important, and it is making common sense. There is not anything unusual here. Okay, but looking at information visually like this gives you better understanding, and at times when you plot these things, then you will understand some issues, and then you can go and further investigate. That is what you are really doing now. Exploratory data analysis you are doing in a very quick way without wasting a lot of time. You are quickly getting to you're grasping the data that you have so that you can do the next steps more effectively. Okay, so these plots anyway we will do that now. So visualizations are not all. Now I am more interested in the numbers as well. Like my property type, I want to see, not here actually you can do, you have square feet, we have done uh, transaction price. If you are interested in bedrooms, you can do that. You are interested in number of schools, you can do that. any metric, numerical metric you can put on x-axis and see that. You can plot as many plots you want, but anyway, always what we do, whatever more relevant things only we'll do that. But let's say you want to see all numerical features with respect to property types, not visualizing, but let me look at numbers. I want to see something like this. My property type on the top, okay, and my apartment here, and my independent house here, okay. Then I want to see TX price, transaction price, square feet, number of schools, all that. I want to see the mean values, averages. So I want to see all the numbers here throughout for independent house as well as, anyway, this is apartment, independent house, all mean values I want to see. Or I want to see mean and standard deviation. Or I want to see mean, min, max and standard deviation. All those things you can see using our pandas functionality. That is basically you will on the DF you do group by and pass your column name you want to group by, property type, and what statistics you want to see. Only one statistics, then I will just put mean function on that or median function. If I want to really see more of the statistics at a time, then we also remember that we did AGG and we passed a list of statistics, min, mean, like that. So anyway, that is what we will do here. So anyway, let us start the coding part now. Okay. So why don't you, what you have to do is that you have to run the cells that are having your header, importing all of your libraries, and then also read your data, real underscore estate underscore data.csv. At least you have to be executing those two steps, and then we can do this. Okay. So what you have to do once you do those execution of those two cells, let us plot SNS dot box plot function we are using. Okay. What we are really doing, we are actually segmenting property type with transaction price, and we are trying to visualize using a box plot. So what we have to do, we have to arguments, what you have to do is that y equal to the column name that you want to put on y, the categorical feature. We are interested in property underscore type. Okay. Then on the x-axis, I want to see tx underscore price column. So again, column name. And where you have to pick the data from, you have to pick the data from df. That is what our real underscore estate underscore csv or real underscore estate underscore data.csv. Okay. Are you there? Are you trying it?
Yes, sir.
You got it? Tell me when you are there, then I can continue. Are you there? You got this visualization on your screen?
Although Joseph here, it is
Yeah,
telling
Joseph.
SNS is not defined. So do we have to define already?
No, in your whatever the header, did you have import Seaborn as SNS? Did you run that cell, code cell?
Okay, I'll run that.
Yes, sir. Got it.
Yeah, let me also. So see, this is my, I'm continuing on this IPNB.
Okay,
So
got
these
it,
are the
Madhu.
things we have
Thank
to
you.
run. Otherwise, these things will not be there. So I'm running this. This is important, and you have to read your data CSV. These are the two things. Otherwise, other things are not needed. Then you can come directly to your whatever segmentations. Here I am actually running my SNS.boxplot. I am passing Y uh, axis, my column property type, which is a categorical uh, type feature, which has two classes property types. Then on the x-axis, I want to plot the tx price. This is a numerical column. I'm segmenting and viewing the box plot using these two columns, and the data is picked from data equal to df. When I do that, it will draw me my box plot. Okay, so that's what you have done. Hope you got it. Okay.
Yes,
Yes, sir,
Madhu.
got
So
it.
then, any question? Anybody else has any question, please? Okay. So once you look at that, you will look for any surprises. So how to read box plot? Already we talked. It actually describes the min, max, Q1, median is Q2, the center, that middle line, and Q3. Box is kind of enclosed with this Q1, Q2. In the middle, the Q2, that is our median. So when you are comparing two property types, is it making sense or not? Okay, let's say we want to draw now for square feet. Only we have to change x equal to whatever our column name for square feet. So it looks like single family homes are more expensive, and it is okay, common sense thing. Okay, now segment square feet by property type. Okay, you have to run the same thing, except that x equal to whatever that column name in the single quotes SQFT. Then you have this view now of how square feet numeric column is with respect to property types. How is it varying? The variability you are trying to understand. So you please do this also. Just any column, any numeric column that might be interesting to you, you can plot and see. At least for now, we have done transaction price, which is our target variable, square feet. Maybe you may be interested in lot size, you may be interested in number of schools, number of cafes, many things you can see, but you can also see using statistics, some descriptive statistics as well, not visualization. Both you can do. Okay, are you there with this
Yes, sir,
visualization?
got it.
Okay. Okay, but you remember this box plot, how to use this box plot and segment my categorical features with some important numeric features that I want to understand. Whatever comes in your mind, you try to remember this syntax. If you practice, you will remember. Then you can move very, very fast, because I've seen some experienced data scientists at work. So they will be sitting with a big monitor with this Jupyter notebook, and they will be typing these commands very, very fast. They'll be seeing that way, this way, because they are able to think through pandas to explore the data. That is a very critical skill. How does it come to anyone? Only by practice, practice, and practice. So any of you are really seriously want to move into those careers, you have to perfect. Only I'm trying to give you good inputs, so that conceptually as well as hands-on wise, you are clear with some things. Now it is up to you to take it to a next level of skill. Okay, fine. After seeing this, some questions we have to answer. It is not just see colorful visualization and feel happy. That is not what data scientists do. Once they get a colorful good picture on the screen, they pause and ask a set of questions, or what questions they were looking for, they will ascertain answers for those things. So now, which type of property is larger on average? You have to answer for me. Is single family home
Independent
larger
house,
on average?
single family.
Independent homes, single family homes. That is how Americans call. So we are calling single family homes. So we are answering. It's a common sense. Good. Which type of property sees greater variance in sizes? So the distance of the box, inside box, the Q1 and Q3, that is making the area of the box, which has higher area. So which type
So
of
again,
property
single
sees
family.
greater variance? So independent homes actually vary in size, square feet, more than apartments. Apartments start somewhere and they don't vary much. That is again a common sense. Okay. Then does the difference in distributions between classes make intuitive sense between apartments and independent homes? Yes, they make intuitive sense. So that is why we have seen this. Okay. So now we have looked at from segmentations from the point of view of visualizations. So at this time, we may be interested in some numbers. Okay, we got like what if we want to compare the two property types across many features. Okay, square feet, number of schools, property tax paid, insurance paid, many things we want to see. Let's say, okay. Again, you could plot more bar plots and see that, or we have a very handy dot group by function in pandas. Okay, so basically using dot group by, we can look at for the categorical feature and its classes many statistics of numerical columns same time using a simple table. So dot group by can segment by a categorical feature and then calculate a metric such as mean, median, max, standard deviation across all numeric features. So right now in our table, we have 26 columns. Out of that, 3 columns are categorical, remaining 23 are numerical. In that 23, one is our target variable, that is tx underscore price. So you may be interested to see all the numeric features, some statistics with respect to property type, how they are varying in apartment type properties, how they are varying in independent home kind of property type. You want to build a little bit of more understanding and want to see any unusual things that are there. That is what you are doing, exploring the data type. So this can be done very easily using group by function. So what we are doing here, df dot group by, we talked at the time of pandas, this group by function, what we are passing to that function, the column name, the categorical column name through which I want to segment the data, that is my property underscore type. And for the rest of the 23 numeric features, I want to see segmented by my property type mean values. Okay, that is what I am really doing, that is what I am really getting here. So if you look at my property type here, okay, then for tx price, what is the average here, beds, what are the average, like that I am seeing, and I can see through all my things at a time. Okay, please do this and tell me when you got this.
Yes, sir, got it.
Okay, so you can do any statistics or you can see multiple statistics at a time, but when you come to these like this, you will not jump to next step, you will just look at numbers. Like basement, we know already there is a problem, that's why here also the problem is appearing. Otherwise typically the average values of apartments are $366,000, here average is 464, makes sense. Bathrooms, on an average apartments have two, single family on 2.8, the square footage, the lot size. Okay, lot size of apartments are smaller, 3,944 kind of square feet, here 20,417. So you will look at it. So let us answer these questions looking at this data. On average, which type of property is larger? Our single family
Single
homes.
family.
Which type of property has larger lots? Again, single family, because it's the average, this is higher. Which type of property is in areas with more nightlife options, more restaurants, and more grocery stores? So you have to go look at the mean values, nightlife per apartments is 7.855, cafes 8.03, shopping 57, whereas single family homes, the average is less. And that is also very common sense. Typically, apartments will be closer to these places. That is how they will be able to sell them. But independent homes will be in gated communities with a lot of big lot sizes. They are more expensive, so they will not be able to do it in the downtowns or center of the cities. Okay, that is common. So do these relationships make intuitive sense, or are any surprising to you? That is what you are really looking at. Nothing really surprises from a property type. This is a pretty decent data. We have already seen some surprises in the basic information and other things, but it's okay. So now let us say you are interested to see all of this: TX price, beds, bath, square feet, not only mean, but also you want to see mean and standard deviation together. So TX price will have mean value, standard deviation value. Beds will have mean value, standard deviation value for each of these categories of or classes of houses or property types. Then we know what we have to do: df dot group by property name dot, you don't give mean, you do this df dot group by. Okay, then you pass your property type. This is my categorical column. Okay, and not one metric, I want to do many metrics. Then actually I use aggregate. Then I pass, let's say I'll put bracket here, parenthesis, and I pass a list of statistics. I can put mean, again quotes we have to give because they're strings, median, let's say standard deviation, like that. I give pass on a list of statistics that I want to get. So let us say I'm interested for again this property type, not only mean, I want to see also the standard deviation. Okay, so I'm running this df dot group by, I'm grouping it by my categorical column called property underscore type, and on that column I am running my AGG function, and AGG function I am passing an argument comprising of a list of statistics that I want to see in the table. Okay, then you will get this kind of table. So please do it and see for yourself. Did you get it?
Yes, sir.
Okay, so you can do whatever is interesting to you. In a next data set, you have a lot of categorical features and some very important segmentations you want to see. You can visualize them as well as look at the numbers and apply a little bit of your statistical mindset to understand the data set. That is where actually, okay, you have pandas with you to get whatever you want, but you have to think like a data scientist. Then you have to get more understanding of statistics. Anyway, the basic statistics only we talked, they are not really rocket science statistics, but as we get into higher level details, more serious statistics will be needed. So get ready for that. Can I move forward?
Yes, okay.
Okay, so with that we learned how to explore data using this segmentation of categorical features with numerical features. That kind of understanding is also important. Okay, so you learned that. Now the last step of exploratory analysis, right now we are not even changed one data also. Okay, finally with this knowledge, the next step is data cleaning. Okay, because this is our first project and we are using this particular template to go systematically so that it becomes it gets internalized within you so that you can use it. But a lot of times as you are exploring, you will also change data. Okay, because by changing data, you will see different things. Your exploration will become much better. So in this project, to be very systematic, I'm not letting you do that. We are doing one step at a time only and understanding. But once you get experienced, you don't need to follow like this. You can, as soon as you got a doubt, immediately do a change and then see the explore the change data frame. Okay, so we will do in the second project in that way, but first project we are strictly sticking to a very standard step-by-step approach because this is our first one. Okay, so now we do the last step of our exploratory data analysis. That's where we try to analyze something called correlation. And again, correlation is about one numeric feature with another numeric feature. Are they in any way related? If one is increasing, another one is increasing, or if one is decreasing, another one is decreasing. How strongly it is increasing, how strongly it is decreasing, or it is not at all bothered. Both of them are quite independent. That kind of analysis also is important because especially when it comes to regression analysis, what is really regression? There is one of our column called tx price. Okay, one of our column called tx price. This is our target variable, and there are 23 other features. Okay, now basically what is regression? All these 23 features combined, are they having, based on their variation, is my transaction price varying? That is what really the trend that we have to really capture. Our machine learning model finally has to capture some underlying trend in this data set. There are many features, characteristics of a property type, and one variable that I am really predicting, that is transaction price. What kind of relationship actually exists between these many input features and that target variable, and is there any relationship? If at all, what is the trend? That is anyway regression task will find it, because instead of human beings finding the trends, the hidden trend, we are letting the computer find using our ML models. That is what we are doing. So again, correlation is also typical, that kind of thing. Correlation is always between two numeric features. Let's say there is a x and there is a y, both of them are numerics. Okay, how x variance is affecting y's variance, that is the study, and that is the statistical study called correlations. We, at the fifth step of our understanding the data, we will do that because we want to know that upfront. Is there any, sometimes these correlations can be not so good for our model building. Like say we are collecting a lot of data. Let's say in our this class, a lot of people have attended my class now. Okay, let's say some 20 people have attended my class. Okay, now I want to predict how many of them will actually, anyway, you will not look for jobs, but let's say land in a very high paid data science job. Okay, land in a job. This is a column I have. Okay, yes or no, land in a high price job. This is my target variable. Okay, I want to predict this. Anyway, because it is yes or no, it is a classification problem, it is not a regression problem. But let me find out what are my input features. Let's say I calculated for every student name is there here, student name. Okay, and this is my index, 1 to 20 students attended. Then percentage attendance I calculated. Okay, then somebody 99%, somebody 65%, somebody 35%, 40%. Let's say this is the data for last 5-6 classes I am doing. Okay, I calculated all that. Then number of assignments completed on time, assignments. Okay, some such metrics I have put here for all of the students so far attended this, and also I put their date of birth, and also I put their zodiacal sign. Okay, and I know now for each of the students who got job and who did not get job. Okay, let's say first got, second no, no, yes, yes, no, no, like that. I have for 100 students this information. This is the data set I have. Now, what should be normally correlated for people to get a job? Who will get jobs after attending the course? There is no hard and fast rule. It depends on the innate skill also, but generally, at least from a lecturer's point of view, somebody who written
Attendance.
assessments completed, scored whatever projects completed, and the score he got or she got. But the zodiacal sign will have very less impact. But let us say when we did a correlation analysis, some zodiacal sciences are linked with yes. Okay, let's say there is a Pisces. Okay, and this is a Leo. Leos are not getting jobs, but Pisces are getting jobs. Okay, so there is a strong relation between the zodiacal sign and people getting job or not. But that is there is no cause for that. It is happening, but that is not very useful. That correlation is not very useful for me to solve this prediction problem. So if I find a strong correlation between this kind of feature and my target variable, better actually I don't consider this feature itself. Okay, so correlation analysis also is important. Okay, we'll understand more as we do the projects, but right now in the step number 5 of our first major step, that is exploratory data analysis, we are doing this step called correlations analysis. Basically, correlations are you are finding relationships between one numeric feature with another pairwise. Okay, that is what we are trying to do. That we will do that. So before that, a quick understanding. I will not make it very complicated. We know how to calculate correlation using an equation and all. We will not go into that. It's not a big deal. But what does it mean? Let us look at it. So what is correlation? It is a relationship between numeric features and other numeric features. Like I have now, most importantly, let's say square feet is one numeric feature. Lot size is another numeric feature. And I have TX price is my target variable. Most importantly, I want to see any relationship between this, any relationship between this, maybe number of schools. I want to see any relationship with that, like that I want to see. But it can be also done between square foot and lot size and numeric feature. So pairwise, it is one numeric feature with another numeric feature. We are checking. You can calculate any correlation between them is there or not. If it is there, what is the number correlation coefficient we call? What is that number? Okay. So correlation is a value between -1 and 1, +1 to -1. It will not be less than that. It will not be more than that. And that represents how closely values for two separate features move in unison. Are they moving together in any particular way, or they are not moving at all, or they are moving in a very weak way? That is what is really we want to find out. Correlation is a value between -1 and +1 that represents how closely values for two separate features move in unison. Okay, so positive correlation is basically correlation. Positive correlation means that as one feature increases, the other increases. Then it's called positive. So a child's age and her height, typically normal children, as their age increases, their height also increases up till some particular age. That's what is a very normal example we can take. That is a positive correlation between the age of a child with her height. Okay, then let's take an example for negative correlation. Negative correlation means that as one feature increases, the other decreases. Okay, I've taken a simple example: hours spent on studying and the number of parties attended. If you attend more parties, because the time spent on parties, your time spent on studying will reduce. That is a typical negative correlation between these two variables: number of parties attended versus hours spent studying. Okay, then Correlations near -1 or +1 indicate strong relationship. Okay, high correlation. They're definitely moving very strongly in that. Those closer to 0 indicate weak relationship. We can calculate this number using an equation. We can find out if it is close to -1 or close to 1 means strong correlation is there. If it is closer to 0, weak relationship is there. And if 0 is there, then it indicates no relationship. Okay, so that is what we have to really understand between our numeric features. Especially we'll be more interested in our other features with our target variable, because that is what is the most concern. But generally also we can look at remaining numeric features with every other numeric feature. So far clear? Any questions? Can I move forward?
Yes, sir.
Okay, so this is a scatter plot of a data between two numeric columns x and y. Okay, so if you calculate for these data points using the statistical equation, the correlation is positive 0.8, and if you plot the data, it looks like this. There is, you can see a trend. As x is increasing, y is increasing. Again, as y increases, x also increases. That is, correlation is mutual. It is not that x to y, it is y to x also. It is between x and y. This is the correlation. Okay, so you can see even in your scatter plot the trend of x and y, and it is at 0.8. It is pretty strong, not strongest. Strongest means 1, but it is decent correlation is there. Then let's say you have something like this scatter plot. There is a data x, data y, and when you plot a scatter plot, the data is like this. What is the trend and how to understand the correlation here? If you calculate correlation of this data set, it will be minus 0.8. Okay, it is, correlation is there, but it is a negative correlation, and decently strong negative correlation is there. Let us say this scatter plot. Okay, if you can see, it is really almost moving like a linear line from x to y. So if you calculate the correlation coefficient of this data set, it is close to 0.97. It is a very strong positive correlation. X increases, y increases. They are going together. Okay, in fact, if x is there, y is not needed actually in the feature also, because they are almost one and the same. Okay, they are talking about the same thing. Then we can remove one column from our feature list also, because they are one and the same. Are you there? Then let us say this kind of data, scatter plot. You can't really notice any particular change. Sometimes it is increasing, sometimes it is decreasing. But if you calculate for such a data, a very weak positive correlation, almost close to 0 is there, 0.3. Okay, and a data like this, if you calculate correlation coefficient, we can create data with that kind of using our NumPy, and that is how these are plotted. So if you calculate, it will be 0. Okay, so that analysis we are doing with respect to our data. So again, numerically, there is a function in pandas called .core, CORR. If we run that function on our DF, it automatically calculates all correlations between all numeric features and puts a big data frame and gives all the numbers to you. Now all those numbers you can pass on to a visualization which SNS or Seaborn produces. This is called correlation heat map. There is a function SNS dot heat map function, and you pass the right arguments and adjust a little bit of that visualization. You will see such things, and you have to know how to read it. Okay, we will come to that very quickly. So right now you do this correlations. I'm calculating correlations here. Okay, correlations I'm calculating, and calling it as correlations variable I'm giving. whatever variable you give the right spelling and use the right spelling later on when you are plotting. Otherwise, you may have some errors. So do that. What I'm doing here, I'm running that function simple df dot corr. Okay, this is a pandas function. Okay, correlations. Then what it does, the correlation object is, it returns after calculating for every numeric value with every other numeric value, it calculates this correlation coefficient and throws out a big table. Again, the table type will be your pandas.data frame type object it gives you. Now this object, I can pass it on to my heat map graph, then it will produce whatever I want to see. Did you do this step?
Yes, sir.
Okay, now you can print correlations. Just you, in the next cell, you just tell correlations or whatever you gave here. Then if you see a very big table, okay, so if you look at it is with tx price correlation is calculated. It is same. That's why it's always 1. Beds with beds 1. So if you look at there is a diagonal where for all these it will be 1, because your whatever this function is calculating correlation of one numeric value with same numeric on its own. That will be always 1. Okay. But anyway, this is the numbers it has calculated. But again, in a large table, seeing this number is not very convenient. It is important to notice that the correlations for basement are nan, because it did not calculate them, because it is only once always. There is no variation in that at all. Okay, this is expected because right now the feature doesn't vary at all. Its standard deviation is 0. So anyway, that is not useful. But whatever, these numbers can be converted into some useful visualizations. Okay, so there is a useful visualization in our Seaborn library that is called SNS dot heat map function. Okay, we have to use that to create our this correlation heat maps to understand in a better way. Okay, so again, this heat map, SNS.heatmap, has many arguments. Don't worry, actually I'm not covering all of them, and it's not needed. Okay, as long as we know it is there, based on your interest level later on, or want to see something that you are unable to see, then you have to use some more arguments. Don't worry at that moment. We'll use some simple arguments only. There is something called CMap equal to argument. This actually controls the color palette used in the heat map. Because it's a heat map, we have to always understand using color palettes. Okay, many options are there. So we are using this string, capital R, small d, capital B, small u, underscore, small r, red, blue, underscore r. Basically, what is it? It paints your heat map with red and blue color coding. Okay, which is a diverging red blue color map. So positive correlation values will be red. If you want to use a color coding and understand the graph, positive correlation red, negative correlation values will be in blue. Okay, when you do that, you will get something like this. Okay, so do this code. Hope you are able to see this. Okay, the first one is plt dot figure, and in that I'm controlling the fig size, and I'm giving a tuple 7,6. You want to increase the size, you can increase, but as you increase, alignments will go bad. Okay, so don't increase very in a big way, but whatever you can see on your screen. So here I did it plt dot figure fig size argument. I'm passing a tuple in that 7,6. This is the size of the visualization. So how are we using SNS.heatmap? Look at it. SNS heat map requires many arguments, but the most important argument is your calculated table. Using df.core, you calculated a table called correlations. You have to pass the table. Then here I'm only using one argument, CMAP color code I'm giving with that string. You can check the documentation. Many other color codes also are there. Okay, this is red blue to indicate positive correlation versus negative correlation. Tell me when you have got this kind of picture on your screen. Got it? Okay. So anyway, it's a good picture, colorful picture. We can see and enjoy, but then we have to figure out how to read this map. Okay, that let us do that now. Okay, we want to see the heat map and how to read the map. Again, what are we most interested in this is actually I want to see any correlation, either positive or negative, that is existing, strong correlations that are existing between my target variable and other numeric features like square feet, like college graduation, all these kind of things. I want to see that. So how to read this? If we read this first, anyway, the topmost is the target variable, tx price. Again, if you look at here, tx price, again bets is on the y-axis, bets is in the y-axis. So actually if you look at the diagonally from here, all the dark red squares are there. So it's a mirror image of the first half and second half, because it is calculating correlation on its own and with respect to every other thing. That is why this kind of visualization is coming. So how to read it? First, look at the top one. Okay, perhaps the most helpful way to interpret this correlation heat map is to first find features that are correlated with our target variable, that is our tx underscore price. Okay, then first scan the left side to find the row with tx price. So I'm scanning the left side, the row with this transaction price. Okay, I want to track this row. Okay, this is actually tx price, and there are this red the small squares with various colors, very light blue. Actually there is no dark blue at all, and there is no dark red at all, but little bit varying red is there. So first scan the left side to find the row with tx underscore price. That's what we are doing. Now you go and see wherever very strong red is there, then go down. Let's say here somewhere in this row, what is strongest red? Somewhere here, let's say. Then I go here, then some kind of correlation, positive correlation, not very strong. It is actually strongest with on its own. Okay, whereas little bit positive correlation exists, like between the college graduate and this property tax and all that. Scan the row to see if any of the boxes are either dark red indicating strong positive correlation, or dark blue strong negative correlation. Okay, then you look for that. Okay, meaning if there is a strong red, there is a positive correlation, it is close to 1. If there is a strong blue, then there is a strong dark blue, there is a strong negative correlation. So if you look at this from a transaction price point of view, actually there is no strong blue with any other numeric feature. It doesn't have any negative correlation, at least that we can establish from this map. There is very minute positive correlations with some other, like here let us go through this. Square feet has some positive correlation, meaning square feet increases, tx price is increasing, but it is not very strong. Then come here, somewhere here. Okay, property tax, these are the things we can, in this case it doesn't look like many features are strongly correlated with the target variable. Okay, there is a weak positive correlation between TX price and property tax and square feet kind of things. Okay, that is how we read our seaborne heat maps diagrams. Any questions?
Madhu, do you have any correlations with value 0? I mean,
What is
no
that value?
correlation at all.
No, anything very light blue are actually very weak correlation. If you look at here, this one, let us move down, 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 down. Like TX price with nightlife doesn't have much correlation. But anyway, you can't say by seeing only the map. Now we may have to increase this map with some values to see that. Okay, because you are asking the question, we can improve our seaborne heat map visualizations. Multiple arguments are there, and it is not our goal to even do that. You can learn it yourself, but some things I will show it to you. One is that actually always do it background to white. Now actually we have set our SNS style to dark grid, because in the header already we clicked there. You want a white background. Any correlation not calculated, if you look at it in this basement, actually correlations are not calculated here. Basement from a horizontal way, because there is no variation. It is again, if you look at from basement from the down here also, it is again not calculated at all. So it is white. Okay, to kind of ignore that, always change your background of your heat map to white. Then whatever is not calculated will become white. It will not unnecessarily create noise as you are reading your map. Okay, change the background to white. This way zero correlation will show as white. Whatever you ask, na, zero correlation is for basement, that will be shown as white. Annotate the cell with their correlation values. So whatever you calculated correlation calculations you have done, you put them into that small squares of color coded squares. You format it in a particular way. Don't put a high precise number, but let's say do it 0 for 0, 1 for if it is 100, some values like that, minus 100, plus 100, plus 80, minus 80, like that. You can see very clearly. Annotate, there is an argument called annotate equal to true. It will calculate and put there. Then, as I told you, this whole square kind of map, diagonally if you cut it, it is a mirror image of same thing. So if you want to not to see the noise, then you can remove the top triangle and see only one part of the triangle if you want. Sometimes actually I understand using all the picture. Triangle doesn't make sense to me. I don't know why. But then drop the legend. Here actually there is this bar is there, color coding bar. Okay, it is dark red to dark blue, and the numbers it is saying. If numbers are already there, already printed in these small cells, you don't need this bar, so remove it. Then your chart becomes a little bit more easy to read. You can do that by changing arguments, but this is not that important. I am just telling. Okay, so first you do the same thing, but again SNS dot set underscore style, you make it white. Earlier on in our header cell we have put a dark grid. In this, just make it white. Then at least zero correlations are very clear. Okay, there is a white line there, horizontally and vertically. Okay, so if you do that, Seaborn has several different themes. The default theme we use is called dark grid. That's what we have been using. You can change the theme with SNS dot set underscore style. You only need to run this once. Okay, and the theme will persist until you change it. Okay, whenever you want to change it, you have to change it. Otherwise, it will persist. You don't need to type every time. Change the theme to white here. Then at least zero correlations will be white. Okay. Also make the figure size, just to see little bit bigger figure, 10 by 8. So PLT dot figure argument fig size equal to send a tuple of 10 comma 8, little bit bigger picture. See how the cells for basement are now white. Okay, so you can do that. This is a little bit modification that we are doing to the map. Did you do this? Okay, so anyway, these are all not really rocket science issues. I'll move forward. Then, as I told you, I like you want these colors are very confusing. Really, we cannot differentiate what is dark red and little less dark red. All that is very tough to do that. So what I am doing here in my SNS.heat map, I am actually calculating correlations into 100, whatever value, precise value calculated in my table, I'm multiplying by 100 and I'm formatting with 0.0f, means actually to format the annotations to a whole number. If you look at it, tx price on its tx price is 100, means strongly correlated, but that is not important for us. But we told property tax and tx price are little bit positively correlated. If you look at it, the value is actually 54. Then the next one, insurance, is 53. Then square foot is actually 47. So there is not very strong, but 47 means 0.47 is the correlation coefficient between tx price and that. So wherever you go and look at the values, anything anything higher than 60, plus 60 is there. Okay, color and number, if you see that, you will figure it out. Okay, so you can pass to your whatever annote, ANNOT equal to true. By default it is false. When I make it true, it calculates, but calculation I'm controlling using, I'm multiplying by 100 the calculation and formatting with whole number. Otherwise again it will be not fit in that cell and it will be unreadable. That's why we are doing that. So this is one way to improve it. Then again, don't worry, there are some masks using that you can remove the mirror image if it makes interesting for you. Then you can use the sidebar is irritating, you can even remove the sidebar by making c bar equal to false. So there are many arguments to control how a heat map visualization comes on the screen. You can look at it. Okay, so anyway, don't worry about that. We don't need to spend too much time on this. Okay, but you understand what is correlations and what is actually how to read them, because you want to understand any unwanted correlation between some input feature and your target variable. Then you may have to critically look at it, why it is there, will it cause a overfitting problem, remove it. Or if there are 2-3 input features have very strong correlation, equal number of correlation with your target variable, then do I have to all have them all three in my, because it is anyway capturing the relationship, so I can get away with two. Some such analysis we can do, but we will talk when we start building models, all those things. But for now, what we have done so far is that we got a data set from our customer, a data dictionary from our data customer, and customer clearly outlined what they want from us, a data driven solution to understand the data and be able to build a computer based model, prediction model, which actually does better than their average real estate appraisers. Inexperienced real estate appraisers are making errors of plus or minus $70,000 when they are predicting a fair price for a transaction of a property. When we do a data driven solution using an ML model, it should beat that metric. With that, actually, our customer came to us and they asked, you build model, a winning model meeting that metric end goal, you submit it to us and we will take it forward. And that is why we are in this project. So in that, to learn and do this project very systematically, we converted in or made it into 5 big steps, so that systematically we will learn and do this project, and that becomes a kind of template for us to take up any other project. And in that, the first step is exploratory data analysis. So when data comes, You have to really try to understand the data by spending some good time. And I told you these kind of issues, exploratory data analysis, data cleaning, feature engineering, they are open-ended kind of topics. Problem with any open-ended topic is that if we don't have a purpose, if we don't have a direction, we will spend a lot of time in a very useless manner. So in order not to get into that situation, we are using the template, and then in this first step, we have completed all 5 steps. We got the data, we loaded it into our data frame, we looked at the basic information, the shape, size, some descriptive metrics, generally understood the data, made notes wherever we found a little bit of issues. Then we looked at the variations or distributions that are there within the numeric features. Then we continued on the categorical features. And today we looked at categorical features side by side with numeric features, understood a little bit more about the data. And then we looked at all numerical features, how they are behaving together. Do they have any relationship? That also we did it by doing a little bit of correlation analysis. And in that whole process, we are using both numerical way statistics we are using as well as visualizations we are using. So the best way is that to use both and don't spend too much time, but within the time you spent, get a good grasp of your data. And this is a very important step. As you practice more and more, then you will get to know about this. But a good data scientist will be able to explore data pretty fast in a very purposeful manner. So please keep that in mind. Okay. So anyway, I executed the steps. So here, same steps that you have done, I am also executing here. Okay. Then what we did, aggregated with mean and standard deviation also for property type we have seen. So this kind of table has come. I can go and see any surprising things one by one, metric by metric, or wherever lot size. There is a issue we have seen here. So look at here, what is the lot size mean for property types, and this again we have to carefully look at only without segmentation, but generally lot size we have seen a problem with standard deviation. Okay, so just you can go horizontally and look at all the data carefully, because that is what we are doing. Then correlations, we have calculated correlations and it has returned a big table. Okay, and the table's type, if you check, it is a data frame. It is a PD data frame object. So whatever we can do with PD data frame, we can do with this correlations object. If I print this, all the calculations have been done here. Okay, but somebody is used to reading this data, you can read it. Otherwise, we can visualize using our correlation heat maps. Okay, simple way to use without any many arguments is this one. And we looked at this and understood how to read this, and then we can improve it by making white style background. Then we also talked about calculating all the values and annotating them within the picture. Okay, then we have used a mask to remove the second half of the picture. Okay, then we also can remove this C bar if it is irritating you, and many more ways you can see that. Then maybe you will be able to read it better. Okay, clear? Any questions?
For me, it is displaying mask is not defined.
Yeah, actually that code in this, it is not here. Mask is defined. In my code, that mask definition is there. So it is not there for you. That is why it will give error. But don't worry, I will send the IPYNB file. You can see that. Again, don't worry about that code. I also don't understand what is that code. Okay. Because it is using very serious NP type of things. Only thing is that wherever you go, all these pieces of code will be available to improve visualization of heat map. You run that code with the right arguments, it will give you. But whichever you are comfortable to read, use that kind of map. Okay, I will send you that, not a problem, Amir.
Okay. Okay.
Okay, so any other questions? Okay, if you don't have any other questions, so let us stop here. So let us again get back on next Monday with the data cleaning step. Okay, so bye bye everyone, have a wonderful day.
Bye, sir. Thank you.
Thank you, Madhu.
Yeah.